Hello pre-calculus students, this is Mr. McAllen speaking, and today we're going to work on solving rational inequalities. And we're going to do that by using interval testing and writing up intervals. So the first example I have is one I made up. It's just a simple polynomial over a polynomial, and we're going to look for where this polynomial is greater than, not the polynomial, sorry, rational function is greater than 0. So what we're going to have to first do is figure out when it's equal to 0 and when it's not defined, and put that on the interval. And if you recall, we do this by factoring the top. So I'm going to factor the top at x plus 5 times x minus 2. That's in the numerator. And in the denominator I have x minus 3 times x minus 3. That would be a double root in the bottom for that polynomial. And actually that would be one vertical asymptote. So and when is that greater than 0? So what we do is when we draw out our number line for interval testing, we're going to label our zeros. Our zeros are going to be found in the numerator. The zeros are at x equals 2 and at x equals negative 5 when we set these linear terms equal to 0. And the function is undefined wherever the denominator is equal to 0. So that's going to be at where x equals positive 3. So on our number line, what we want to do is establish all those points on the number line so we can interval test around them, and we want to make certain notation. So for example, I'm going to refer to this polynomial as f of x. So I'm going to write here f of x, its sign. On the bottom, I'm going to write x so that values that appear underneath, like at negative 5, I'm going to put a 0. So because the function values can be 0 and negative 5, I'm going to put the next value will be at 2. I'm going to put 0 because that's another 0. But at 3, I'm going to put UND for undefined. Some people will put like a like a dotted line vertical asymptote kind of icon to show that there's a vertical asymptote there. But the real important thing here to solve this inequality is to find the positive and negative values that will result, and also what you should do is you should put you should write out what your test points are that you're going to use for inserting x values into this factor equation. So when I use my first test point, which will be in, I'm just going to highlight it, in this interval, is going to be, I'm going to use negative 6. So when I plug negative 6 into that function, I'm going to get, now I'm going to use like these parentheses. So where that factor function, I'm going to put my parentheses over parentheses. So then I'm going to plug in negative 6, so I'll get negative, and then I'll have another negative. The bottom will be negative when I plug negative 6 in, and negative again. The end result of this interval will be, I'll just put it in red, will be positive overall. When you do negative times a negative in the numerator, divided by negative times a negative in the denominator, you're going to get positive over positive, which will be positive. So this interval will work for this inequality. So let's try another test point, but a test point that is in the next region. So that will be, let's use a test point of, let's say something nice and easy. How about 0? Because that's in that interval. So when I put 0 in, I'm just going to make my parentheses so I can keep track of things. I'm going to get 0 plus 5 is positive, 0 minus 2 is negative, 0 minus 3 is negative, and 0 minus 3 is also negative. So I'm going to end up with a net result of a negative in the numerator and a positive in the denominator, which will be an overall negative value. Next interval, I'm going to put in, now I have to put a fractional value in here. I need like 2.5, I believe. So my test point is going to be 2.5. So when I plug that in, I'm just going to go ahead and do this quickly. 2.5 in the first part is going to make it positive. Oh, this is way too small. I'm going to have positive over positive, and in the bottom I'm going to have negative over negative, and that end result will also be positive. And the last interval, I'm just going to put 4 or 5 in. So I'll put in 4. And when I look at my sign check, when I put 4 in here, I'm going to have, that's going to be positive, and then x minus 2 will be positive, and then the bottom we're going to have positive and positive. So this is going to end up being a positive interval as well. So to answer the question, what satisfies this inequality when is it greater than 0, you would say f of x is greater than 0 on the intervals from -infinity to -5, and the interval from 2 to 3. So that's the end of that problem. Now let's look at another problem we have here. We have another example, same sort of thing. We want to see when this let's call this, we'll refer to that rational function as r of x. We want to find out when r of x is greater than 0. So we're going to first find the zeros, and that's easy because that's just set the top equal to 0, and you have x equals -2. The bottom, we want to find where it's undefined. So it's undefined at, well, we have to factor the bottom, so it's going to be x squared minus 9. We'll factor into x plus 3, x minus 3. So I have, it's undefined at x equals -3, and from this root, and then from this root we're going to get x equals +3. So I'm going to draw up a number line just like I did before. This time I'm going to try to make a little bit more room. I'm going to have -3, I'm going to have -2, and I'm going to have 3, and I'm going to put 0 for, actually that's not 0, this is undefined, this is undefined, and this is a 0. I'm going to interval test. No, I'm just going to put the x plus 2 over x plus 3, x minus 3, just so I can keep track of that. I'm going to, as far as my test points and my function, this will be r of x, and down here this will be just the x values, just so I can keep track of things. So so my test point over here will be like -5. I'll plug -5 into this equation, and I'm going to get a negative on the top, and on the bottom I'm going to get negative and a negative. That result will be a negative. I'm just going to move this test point will be -5. So right here I'm going to write in a different color. I'm going to write negative. That's not a different color. Let's use that. That's negative on this interval. And then I'm going to plug in -2.5. So if I use -2.5, then the top is going to be negative. This will become positive, and that'll be negative. So the net result here will be positive on this interval. And I'm looking for positive, so I'm just going to highlight that as a solution. So this interval works. The next interval I'm going to check, I'll put in 0. And when I put 0 in, I get, for the top, I'm going to get positive, and the bottom will be positive, and then I'll have negative. So this will result in a negative interval, so that's not going to be an answer. And then the last one, on the other side of this asymptote, and that was an asymptote there, I'm going to plug in 4. So when I plug in 4, I'm going to have a positive over a positive and a positive. So this will be a positive interval overall, and then I'll highlight that because that should definitely be marked as a solution. So those two intervals are solutions. So I'm going to now just draw or write in the answer. So r of x is positive on the intervals from -3 to -2, and from 3 to infinity. Last problem we have to do is sometimes you get equations which ask you to add fractions, and you get a rational equation, and you want to make sure that you have the right solution. So the first thing we need to do here is have the same denominator. So the common denominator, or the least common denominator, will be x plus 3, x minus 1. And when I use that common denominator, the top of the first term is going to become 5 times x minus 1 to compensate for changing the denominator, and on the other term it's going to be x plus 3. I'm going to combine terms and simplify, so I have 5x minus 5 plus 3x plus 9 all over my common denominator, which is x plus 3, x minus 1. Notice I'm not going to multiply the polynomial in the denominator because it definitely tells me more information about it, leaving it in its factored form. The numerator I'm going to, wait, this is less than 0. The numerator I'm going to simplify, so I've got 8x plus 4, and this is going to be x plus 3, x minus 1. When is that less than 0? So again, I go through the same routine as before. I am going to solve for the zeros. So the zeros are going to be at, when I set the numerator equal to 0, I'm going to have -1/2 will be my 0, and the undefined values, it's undefined at x equals -3 and x equals 1, because that's what makes the denominator 0. I number line it quickly. I'm going to have -3, I'm going to have 1, and then I have -1/2. -1/2 is a 0. I put a u here and a u here for undefined, and now I'm just interval testing. So I'm going to put in I'll write the equation above, 8x plus 4 over x plus 3, x minus 1. I'm looking for one that's less than 0, so I interval test the test point. I'll use -5. -5 is going to give me a negative over a negative by negative, so that's going to make a negative interval. Then I'm going to use I'll use -2. So I'll use -2, so I'm going to have a this will make negative on the top, and then this will be positive and negative, so I'll make a positive interval. I'm going to use 0 as a test point. That'll give me a positive over a positive by negative, so this will be a negative interval. I'm going through this quickly because we did review it, and I don't want to take up too much more of your time. And then I'm going to put 2 in as a test point, and that's going to become positive over positive, positive, so this is a positive interval. So our answers now for this, the function is negative on the interval, because they asked for when is it negative, from -infinity to -3, and on the interval from -1/2 to 1. I hope this video has helped you understand how to use interval testing to figure out solutions to rational inequalities, and I look forward to hearing your comments. Take care.